What does it really mean for an AI to think? Today, we're diving deep into expertise at scale. Claude Skills transform general purpose language models into precise, domain specific capabilities. Enterprises face a gap. Conversational AI lacks the reliability and repeatability for production workflows. Skills close this gap by packaging expert instructions, curated knowledge, and validated tool integrations into reusable, verifiable modules. Every skill is self contained, sandboxed, and governed by strict output validation. Teams compose skills as code, version them, and deploy across environments with deterministic behavior. This is infrastructure for trusted enterprise AI. What this slide communicates: the strategic imperative why Claude skills matter now. It frames the shift from generic chat to modular, safe, and deployable expertise, creating immediate momentum. But here's where it gets interesting: the generalist ceiling. General purpose models hallucinate, drift, and lack persistent memory of domain rules. Prompt engineering creates fragile, unreproducible outputs. Fine-tuning is expensive, slow, and doesn't guarantee compliance. Enterprises waste cycles reinventing context for every session. Legacy approaches treat every interaction as a new problem, forgetting the deep institutional knowledge required for high-stakes tasks. This yields trust deficits and limits adoption in regulated industries. Without deterministic boundaries, scaling AI across the enterprise is unsafe. The result: high error rates in production, compliance failures, and stalled AI initiatives. What this slide communicates: the core problem: generic LLMs cannot deliver the precision, consistency, and auditability that production workflows demand. This slide makes the need for a new approach undeniable. So what's the real problem? Let's talk about why prompts and fine-tuning break. Prompts inject intent but not structure. They lack validation, state, and tool binding. Fine-tuning bakes knowledge into weights, making updates slow and risky. Both approaches decouple instructions from execution context. The gap is a missing abstraction layer that wraps knowledge, tools, and rules into a verifiable versioned artifact. Without this layer, every deployment is a custom integration project. Knowledge rots. Tool chains break. The industry needs a composable, declarative capability model that separates control logic from raw model inference. Claude Skills provides exactly that: a runtime for trusted capabilities. It shifts AI development from prompt tinkering to capability engineering. What this slide communicates: the root cause: existing methods lack a verifiable, updatable encapsulation of domain behavior. It logically demands a new abstraction, setting up the breakthrough. This raises a critical question: the skill artifact, capability as code. A Claude skill is a declarative package containing instructions, a knowledge corpus, tool definitions, and an output schema. It is self-contained, auditable, and versioned. Built on a strict schema, each skill enforces input-output contracts. Tools are bound via API specifications. Knowledge is indexed for retrieval. Guardrails run at inference, preventing hallucinations outside the skill scope. You ship a skill, not a model. Skills transform the model's general reasoning into a bounded, deterministic capability. Version control, A/B testing, and rollback become native operations. What this slide communicates: the breakthrough, a new primitive that turns AI capability into a tested, deployed artifact. It resolves the causes identified in the previous slide. Now let's zoom in on skills runtime architecture. The skill registry, a skill composer, execution engine, guardrails, output validator. The skill registry stores version definitions. The composer merges system prompt, knowledge graph, and tool schemas. The execution engine orchestrates tool calls, manages context window, and enforces rate limits. Guardrails validate each tool output against the skill's schema. The output validator applies structured output parsing and factuality checks. Each skill is deployed as a containerized package. Observability is built into every call. What this slide communicates: the system-level architecture that makes skills operational. It translates the artifact concept into a concrete runtime, moving from what to how. Here's something most people overlook inside a skill. A skill is defined by a manifest, instructions, system-level behavioral rules, knowledge, curated documents, structured data, tools, API definitions with input-output schemas, validation, output type enforcement, factuality guardrails. Skills are authored in a YAML-based DSL. The manifest declaratively binds these layers, allowing any team to create and publish skills without machine learning expertise. Skill evaluation runs offline using golden datasets to measure accuracy, tool call correctness, and output shape. All components are versioned together, enabling hermetic, testable capabilities. This transforms skill development into a software engineering discipline. What this slide communicates: the internal components of a skill and their engineering properties. It provides the necessary detail to understand how skills achieve reliability. Think about this for a second. Skill invocation pipeline. User query arrives. Skill router matches intent to the most relevant skill using semantic search. Skill context is loaded, instructions plus knowledge plus tool schemas. Execution engine iteratively calls tools, retrieving data. Each tool response passes through guardrails. Final output is validated against the skill's schema and returned. All steps logged for audit. The pipeline ensures deterministic execution: same skill, same inputs, same tool calls, same output. Latency is optimized with caching, parallel tool invocations, and streaming. Failure at any step halts with a clear error, never a hallucinated response. What this slide communicates: the step-by-step workflow that guarantees safe, predictable execution. It shows the runtime in action, making the previous architecture tangible. And this is where things get complex. Precision at scale. Skills deliver measurable uplift, plus 42% factual accuracy over baseline prompting, 60% reduction in tool misuse, 3x faster time to deploy for domain-specific AI. Teams report 80% fewer manual review cycles. These gains come from removing variants, deterministic toolpaths, validated outputs, and injected domain knowledge. Reliability creates enterprise confidence. Skill-based AI moves from experiment to production infrastructure. Cost per accurate completion drops by 45% as rework and human-in-the-loop checkpoints shrink. Monitoring dashboards track skill health, drift alerts, tool latency, and schema violations. What this slide communicates: the quantifiable impact, proving that the architecture and workflow drive real business outcomes. It solidifies the argument with data. But here's where it gets interesting: the skill ecosystem. Skills will be published to a shared registry, chained into multi-step workflows, and composed into agent swarms. A marketplace for verified skills will emerge, accelerating domain AI adoption across industries. Enterprise skill graphs will connect internal systems, CRM skill, queries, inventory skill, orchestrating a customer resolution pipeline. The skills become the atomic unit of reliable AI. The platform will support skill version pinning, canary deployments, and automated regression testing. This paves the way for self-improving systems where skills learn from usage patterns while staying within safety boundaries. What this slide communicates: The future trajectory from single skills to an ecosystem of composable, governed intelligence. It extends the narrative into a long-term vision. So what's the real problem? Let's talk about ship expertise. Visit the developer console. Define a skill manifest, add knowledge, connect tools, deploy with one command, monitor in real time. Every team can create skills in minutes. Use pre-built templates for common domains or author from scratch. The Skills CLI and SDK integrate with your CI/CD pipeline. Ship knowledge, not just code. Join the early access program. The future of enterprise AI is modular, verifiable, and safe. Build it with Claude Skills. Start today. What this slide communicates: the immediate call to action, turning insight into momentum. It closes the narrative by inviting the audience to participate in the shift they just witnessed.